everything in existence. If you're not dropping knowledge, abolished because you're ignorant. A top-notch scholar with honors, I'm so gifted. Live is the most vicious, honest, and prolific. I drop diabolical product with no gimmick. Astonish the flow critics, rhyme with the most lyrics. I paint pictures jotted and dotted, but won't print it. My project is photogenic, I am the most vivid. Man, I got a brain the size of the most biggest. Wide as them cold rivers, wise as them old niggas. Tired of this dope, how could you rhyme it but don't live it? Watch it and go spit it, stop it, I know physics. Breaking your physical, demolishing your spirit. The struggle got me thinking demonic and so wicked. Man, I'm so deep, I'm bottomless, yo, kill it. Why put the flow rhyme behind him, it's so senseless. Voice with the text, throwing up the set. And the spot so hot, the ceiling starts to sweat.
Hello, my name is KemPtah Geometry, and I want to show you some concepts of unit fractions. Also, I want to get into Hoven, you know what I mean, half in numbers, and how to look at the solution in the problem. That's the whole thing about it, the solution in the problem. So what I'm trying to say is that, so like if you want to Hove, well, you want to make half of that if you want to divide it by 2. You know what I'm saying? It's all on how you look at the numbers. Let's hold this. Let me just show you the mechanics. Half of 2 is 1. Since 5 is not doesn't have properly, like it leaves decimals and fractions, you see 5 as 4, boom, 4 plus 1. The reason we translate and transform 5 into 4 plus 1, because now we can hold, and half of 4 is 2, and you put this 1, whatever you got right here, next to the next number, which makes it 15. You know what I'm saying? And since 15 doesn't divide evenly, you say 14 plus 1. And don't forget that you got decimal places. And half of 14 is what? 7. And you put that 1 next to the 0 behind the decimal place, which makes it 10. Half of 10 is 5. And you finish. You know, it's all about seeing, you know, the solution and the problem. Synergy of sides, that's what it is. So like if you want to divide a long number like 1, 9, 7, 8, 9, 7, 8, 9, 7, 7, 1, 2. This could be done very easily. You got 19 right here. So that's 18 plus 1, right? Half of 18 is 9. You put that 1 next to the next digit next to it, which is 17. And 17 is 16 plus 1. 16 is, half of 16 is 8. And you keep going down the row with that method, because you put the 1 that you found right here next to 18, that's 9. And the next number that's divisible, that's less than 9, is 8. So it's 8 plus 1. Half of 8 is 4. And you go down. 17 is 16 plus 1. Half of 16 is 8. Put that 1 next to 8, make it 18, that's 9, right? The next number below 9 that's divisible evenly is 8. So 8 plus 1, half of that is 4. Put that 1 next to 17. 17, 16 plus 1, 8. Put that 1 right there next to 17, 16, 8. Put that right there. The closest number to 11 is 10 plus 1. Half of 10 is 5. Put that 1 next to 12, that's 6. And we finish. That's the answer. Now, I want to show you some unit fractions, unit measurements. I want to go into how to break down unit fractions to measurements. You know, see the synergy between the two. We're going to do 1 and 4 equal. 1 and 4 equal what is the component fractions? This is the unit fraction right here. And the component fractions is over here. You know, like parts and whole. So the formula, I use a binary formula in which I add 1 to 4, which makes 5. And you got 1 on top plus what? 5 times 4 is 20, so it's 20 over 1. And you finish that. But instead of, we're going to look at how it looks. The reason they call it unit fraction, right? Because each number on top, that is the unit that's going to be divided. That's going to be, marked up, marked up. So if you got 1/4, the unit length is 1, and how many times that unit length is going to be divided into to make it a real unit length in the first place? It's 4 times. So it's 1 in the middle and 2 on the sides. And you shade this part, boom, just to show that that's 1/4. 1 out of 4, 1 out of 4, 1/5 is, you got 1, 2, 3, 4. 1, 2, 3, 4, 5. So you shade one in, that's 1/5. How you doing?
You know how long you may be in here?
Probably another half hour, because I just came up in here.
So I come back like 3:30?
What time is it?
3 o'clock.
3 o'clock? Yeah, around that time.
Cool.
All right.
Not rushing, just check.
Okay. All right, just check on me though. All right.
Because you know it's supposed to be group study, right?
Yeah, but I'm doing this real quick. I don't do this every day. You know what I'm saying? This is Black Supreme Mathematics, which trumps every math that you ever learned in the school or anything else. This is our math. Black Supreme Mathematics, meaning the first and the only mathematics. All the math they learn in school is trigonometry. And I got the proof I can kill any teacher student with my mind,
Look it up.
So that's what I'm doing. All right. So going back to what I was saying. You got a plus. So I put that down. Instead of making, just like we did right here, we ain't gonna do it right here because the number is too large. So what makes 20 is 4 and 5. So the first thing I would do to make it equivocal is to divide this into 5. 1, 2, 3, 4, which is 5. So when you say 1 over 20, you're really saying a fourth of a 1/5. A fourth of 1/5, which means that you got this, right? This represents 1/5 now, right? This represents 1/5, but you're breaking that 1/5 down and making this into a unit length. You know what I'm saying? So once this becomes a unit length, now what happened is you break this little piece into, you say 1/4 now. You know what I'm saying? So what I'm saying is a fourth of 1/5 is 1 over 20. And see how easily we just zoom in and zoom out? You know what I'm saying? That's because we could use zoom in, you know what I'm saying? -0. If you want to go back up, it's +0. You know what I'm saying? Look at the whole picture like, boom, it's 120. So that's what I want to show you. Instead of making the long ruler where you just got like a long of 20 boxes, you could just break it down and make it simplify. That's what blackness means. Simplification of complex elements and allowing them to work as one of a kind. So that's what I want to get into. Now I want to get into a quick lesson about squaring the circle, and not only squaring, but we squaring, we cubing, we enrooting. You know what I mean? Enroot. You know what I mean? What I mean by that? Enroot could be, if you say n equals 2, we talking about square roots, If you say n equals 3, that's cube root. You got fourth root and all that other stuff. So this is the thing where I'm going at. I'm gonna draw up the eye of Hebrew, just to remind us. All right. 1/4, right? 1/16, 1/2, 1/64, right? 1/32, and 1/8. That's the RFA rule. So, when we use the circle is 0. And this is the unit length right there, just like we did in the ruler. But in addition to that, when we do the circle, like for instance, you say, okay, how about we use a diameter of 1 inch? You know what I'm saying? This would be 1 inch. Then we draw a circle around it. Let me draw this one. Make it better. This is going to be 1 inch, right? So that means the circle around here, when you divide 100 into 32, this is what happened is we multiply 1, 2. You know what I'm saying? From the 1 inch in the diameter. So 1 times 100 is 100. And then this right here represents degrees. You know what I'm saying? So when you divide 32 into 100, what you get is 3.125. You know what I'm saying? Inches. 3.125 inches, okay? And this is what we got right here. But in order for you to cube it or square it, what I did first, when you square it, the first level is taking this 1.123, this 3.125, change into a unit length, which is going to equal this, a bigger circle, you know, circumference. You got the circle coming around. I ain't going to draw it perfectly because this is going to be just a representation of what real logic going to happen to it. So right here, you might call it 1 pi inch, right? Which equals to 3.125 inches. You know what I'm saying? But we call it 1. We just made this into a unit length now. You know what I'm saying? So when we do this all over, multiply this, and you get, instead of 3.125 inches, you get 3.125 pi inches. Pi inches. And that's actually the square root of inches. This is equal, 3.125 inches is actually 3.125 inches squared. You know what I'm saying? 3.125, I'm gonna say square inches. You know what I'm saying? And then if you take pi inches and make it into a unit length of a bigger circle, the inches become cubed. And we take this inches as the basis, you know what I'm saying, of all things that sprung out, you know what I'm saying? This is the true definition of self-similarity. Self-similarity comes from self-difference. When you keep differentiating, the same characteristics is going to be on a new basis. So you're going to see it again, but it's going to be a new twist to it, you know? Same thing with the triangle or any other geometric shape. You look at the triangle, for instance. Let me show you the triangle real quick. Like how I got the triangle, the measure of the triangle. All right? You got the measure of the triangle. You got 1 inch right here, right? You got 1 inch right here. And the formula for the triangle is right here, 1/64. But that 1 represents the inches, you know what I'm saying, the unit length. You know what I'm saying? The only thing you gotta figure out is the degrees, which is the 90 that is missing in the RFA rule. Just like we did the circle, we multiply the 1 inches with 90 degrees divided by 64, and what you get is 1.40625 inches. You know? And the thing about this, what is the advantage of doing it the KemPtah way, is because when you get imperfect squares it blurs the pattern that you're trying to find, you know what I'm saying? And the thing is, infinite numbers, just like you got the transcendental numbers and the irrational numbers. All that is just a bigger mathematical progression. It's based on the natural numbers. Even the real numbers or the rational numbers still got to bow down to the natural numbers. Even integers got to bow down to the natural numbers too. The natural numbers is the root of all numbers. So when you divide that, you got 1.40625, and the same thing. If you want to use this right here as a unit length, like you might make a bigger triangle, right? Coming off the basis of the hypotenuse. You know what I'm saying? Because the hypotenuse is 1.40625 inches. So what if we use the hypotenuse now for the legs? So we call it one hypati. One hypati. And that equals what? 1.40625 inches. So when you get the hypotenuse again, when you're trying to find the hypotenuse, all you gotta do is square this out. When you square that out, you go automatically get the hypotenuse. But since we're doing the hypati, short for hypotenuse inches, like where we got it from in the first place, what we do is we do it just like the regular formula. Instead of 1.40625 inches, it'd be 1.40625 hypati. You know what I'm saying? And it goes on and goes on and goes on, you know? Let me show you something else. Another thing is that 1/4 is always in synergy with intertransformable with 4. They inverses. You know what I'm saying? So in other words, if you want to find a new unit length from inches, for instance, so like you got inches. You got 1 inch right here, divided by 4. In order for you to get a new unit length, it had to be either a quarter of it. This is a new unit length. A quarter of it, or it had to be 4 times 1 inch. So that means 4 inches is the new inch. You know what I'm saying? It's a new unit length. Every time you multiply a unit length by 4, it automatically give you a new unit length. And if you divide the unit length by 4, you get a smaller, much older, much more basic unit length. So the new goes this way. You got the new unit length, and you got the origin of the inch. You know what I'm saying? Pre-inches. I call pre-inches, and I call anything over the inch post-inches. You know what I'm saying? So you got pre-inches. You know, that's the unity, because if you divide it in, if you say 2 of them could be unit inches, what happened is you could do that, but it has nothing to do with the inches you're working with. You know what I'm saying? Or it has, its connection to it is not too tight. It's not as tight as saying 1/4 or 4 inches to make a new unit length or old unit length. You know what I'm saying? And unit length is very important, because when you go into the calibrations and stuff, you see this in biology. Biology always go from 1 to 2 to 4 to 8, right? To 16 to what? All them other KemPtah numbers, like 32, 64, 128, 256, 512, 1024, so on and so forth. You know what I'm saying? And that's how cells divide. That's how materials, atoms pull things out from inside of itself and pull it out to the surface so they can manifest it. You know what I'm saying? That's what it does. And it used unit length to do so. I think this is like a natural law, you know, because laws is connection. And what better connection is when you have mathematical progression in complete unity with measurements. You know, like, that's like, when you talk about law, you're talking about connections, you know? So what's the best connection when you make everything one of a kind? And the only law that is real gotta be the black law. You know what I'm saying? And blackness means what? Elements, subdivision, components, modules, you know, parts, united as one of a kind without destroying each other. That's what that is. And that's some trill stuff, you know? That's some good stuff, you know? And that's what I love about that. Many of y'all, and the thing is, it's based on synergy of sides. All you're doing is like saying, okay, positive A equal negative A, you know, and you got the negative D, which is the difference between positive A and negative A, and you got the positive D, which acts as a synergy too. And when you make it linear, when you make it straight, what better